we saw that Spark is basically a distributed application framework to build distributed processing applications, right? So in today's session, the remainder of the session, let's look at the Spark framework architecture, right? So when you build a Spark application and you're running it on a Spark cluster, what would be the kind of architecture that you're looking at, right? So let's begin with Spark. So now to talk about Spark, so we saw that Spark architecture, right? Yeah. So a Spark application is nothing but an application which can be written in a language like Scala, okay, where you can perform some distributed processing, right? So supposing you're working with large data sets which require doing some distributed processing, you can use Spark API to create an application where you get all these nuances of building distributed processing by the way of the Spark API, right? So if you look at a typical Spark program, so the starting point of a Spark program is an object called as a Spark context. Now the starting point of any Spark application is an object called as Spark context. And when you create a Spark program, so you would have a Spark context object. So this Spark context object, okay, when you execute this program on some cluster, okay, some distributed clusters like Hadoop or Mesos, or Spark also comes with its own cluster manager called as Spark standalone, using which you can build a cluster. So now the Spark context object, okay, connects with the cluster manager. Okay, it could be a Hadoop cluster. If you are deploying a Spark application on a Hadoop cluster, so then Yarn would be the cluster manager, right? So the Spark context object would connect to, say, for example, Yarn, and it would request for the resources to be allocated for this Spark application, okay? And the cluster manager will then allocate resources for executing this application on the cluster, right? So say, for example, this Hadoop, say if you're running this application on a Hadoop cluster, so then the Yarn cluster manager would allocate sufficient resources for this Spark application on, say, 2 of the nodes of a this Hadoop cluster, okay, which we can call it as worker nodes, right? Now once the Spark context receives access to those machines, okay, so the Spark context would spawn off processes called as executors on those machines or those nodes which is allocated by the cluster manager, okay? And within these executors, the Spark context would then execute this application within these executor processes that is spawned by the Spark context, okay? So the executor processes can have multiple tasks running on them, okay? And basically the data can be held in RAM, so in the cache that is allocated by the cluster managers, and the application executes on different machines. So this distributed processing, so this is distributed processing, right? So and then the Spark context coordinates all these tasks and it completes the execution, right? So this is how a typical Spark application works, right? So there is one object called as Spark context which coordinates the distributed processing of this application, right? So if you look at it, the functional programming aspects would come in handy here, because when Spark context spawns multiple processes on the executors, okay, so the Spark context would then send the the functionalities as functions, right? So basically it sends the functions onto different executors, and the executor processes or the tasks basically work on the data sets that is available on these different machines, or like maybe, and like the task execution occurs within the context of these executor processes. Okay, so so if you observe, so this is the driver program. So this is basically your application, Spark application, which you are executing. So this basically sits in whichever the client machine from where you are executing this application, right? So typically the Spark application is distributed as a jar file, right? So because Spark is running on so when you compile the Spark program, okay, so a Spark program is essentially a Scala program, right? So you've seen that, like when you execute, when you build a Scala program, so you can distribute that as a jar file, right? Because the Scala program is running on a Java virtual machine, right? So you distribute this Scala application or a Spark application as a jar file. Okay, so wherever you're executing the jar file, okay, so the code actually resides in that jar file. Okay, and when you create the Spark context, and the Spark context creates the executors on the different nodes of a cluster upon which you are running this application. The Spark context then sends those code, right? So the functions, the functionalities onto the executors, and the job gets executed on the executors. So the whole process of splitting the job into multiple tasks, creating the executors, connecting with the cluster manager, and negotiating for the resources on the cluster, and then splitting the job, and then getting it executed, coordinating all of these. Now all of this you don't have to worry about, right? Because that is what is the Spark API trying to do, right? So the Spark API provides you a way to build this application where all of this comes automatic, right? So all you need to do is, in your code, you have to create a Spark context, and Spark provides an abstraction called as RDDs, which we talked about in our first session, right? So so just like how you have in an RDBMS paradigm, you have an abstraction called as a table, right? So you basically load the data into a table in an RDBMS, and you then process the data on the table or in the table by using an SQL kind of querying language, right? So you run the SQL queries, and you perform whatever the transformations or results that you are the answers that you're looking for from the data, right? Now analogous to that, you can think of a Spark API providing you all this process of doing this distributed processing, right, where you don't have to write any code for doing all this, and it provides you a way to look at the data in a distributed fashion, right? Like store the data in a distributed fashion and process the data in a distributed fashion using a structure or an abstract called as RDDs, or resilient distributed data sets, right? So RDDs you can think of as a distributed memory abstractions, which lets programmers perform in-memory computations on a large clusters in a fault-tolerant manner, right? So just like how you use arrays, right? So when you use arrays, you're not really worried about the implementation of it, right? So basically, the language takes care of providing you all the capabilities of what an array can do, right? So in this case, you saw that Scala arrays supports a whole lot of functions, that you can perform on arrays, right? However, when you store the data as arrays, now that is basically it's not distributed, right? So if you're running a Scala program which uses arrays, now that data in the arrays is all stored on the single machine, right? But if your data set is very large, you cannot process them as arrays, right? Or any other collection objects, right? So this is where Scala comes into picture, and the Spark comes into picture. So the Spark APIs allows you to create an abstraction called as RDDs, right? So for us, for the programmers, an RDD is simply another collection type. Okay, so you can load the data in as RDDs, and automatically the Spark will ensure that the Spark API will ensure that the data that is loaded into RDDs is distributed, right? So when you have very large data sets, right? So supposing you think of, say terabytes of data, right? Now, you cannot just load them into one variable, right? So if you're writing a Scala application. Now, whereas in Spark, you can load this data as an RDD. Okay, so it will hold this data in memory across multiple nodes of a cluster, and you can process this data again, like you can process this by splitting the job into multiple tasks, which is all done automatically. So for a programmer, it is as if like you've created an array, you've loaded all the data into it, and you're processing the data. Okay, so the Spark API basically abstracts all the complexities of performing distributed processing, right? So that's the biggest advantage that you have with Spark, right? So Spark is all about creating RDDs, okay, and these RDDs can be created from any kind of data sources, right? So it could be from Scala collections. It could be reading a file that is stored on the disk. It could be any type of data, right? It could be a text file. It could be an XML file. It could be a database file. It could be an image. It could be a video. It could be whatever it is, right? So whatever the data, it could be data that is stored in Hadoop. It could be data that is stored on some cloud. It could be an HBase table. So it doesn't matter what the source is, right? So it is automatically, you can create an RDD out of that data, and that data is held in the RAM of this cluster, right? So here, Spark is not for storing any of the data. Spark is simply processing the data. So when you're processing the data, you can collect the data from different sources, okay, and you can store it in RDDs, right? And RDD will take care of how it is stored, actually held in memory for processing, right? So in RDD, you have this concept of storing the data and in partitions, right? So so RDD creates basically partitions. So one RDD can be composed of multiple partitions, and each of those partitions is physically located on different nodes of a cluster. Okay, so supposing, for example, you're having a Spark program here, which is now being executed on two nodes of a cluster. Okay, so supposing you say like you want to process some some customer data, right? So you want to do some analytics, okay, and you're using some transaction data and you're performing some analytics. Now, if you want to do something like that, so now this Spark application, is creating a Spark context, which is, creating two executors on two different data nodes. And when it is reading this transaction data, which you want to, basically use for analysis, you are basically, loading the data. And when you load the data, you are basically creating an RDD, okay? And where does that, how does that RDD hold the data? So we don't really, write any code for that. All we do is we load the data and create an RDD. Okay, I'll show you some functions which we use, right? And the Spark API takes care of how this is, distributed, how this is held in memory in a distributed fashion. So I said that we have an, an abstraction called as an RDD. So this RDD structure will have partitions on, say, two different nodes of the cluster. So when you say you're loading the data into an RDD, so that data is loaded into the partitions of RDD, and each of the partitions can be on different nodes of this cluster. So there is one cache here, there's one cache here. So, this data is now held in the cache of the worker node 1 and the cache of the worker node 2. Okay, and when Spark context is processing, when you're performing, say, for example, you're doing some transformations on that data set, okay, which is now held as an RDD. So when you're running any any functions on any functionalities on that data set, now Spark would automatically ensure that, so supposing, say, for example, you are trying to add say some some number to each of the values that are held in this RDD, right? So part of the data is held in the cache of worker node 1, part of the data is held in the cache of worker node 2. So two different partitions of this RDD, right? Now, when you're trying to add something to it, okay, now this is where the functional programming helps, because you are passing this as functions, right? I mean, like, sorry, you're processing, by passing the functionalities as a parameter, like using, like, for example, using the map function. So what it does is the tasks on, say, this machine, okay, would work on the data set that is present in this machine, and it's kind of, so it is applying that function on the data that is held in this machine. And similarly, the task that is run on this machine is applying, the functions onto the data set that is held in this cache, right? So this way, you're splitting the job into multiple tasks, and you're holding the data on, multiple machines, and, you're executing the tasks on different machines on the data set, which is also distributed on different machines. Spark is a third generation distributed processing system. So Spark can make use of multiple cores that are available on the processors for each of the nodes of the cluster, and depending upon the resource that has been allocated, say, for example, if you are allocated just one core of processor for this executor, then there will be one task. Supposing if there are two cores allocated for this executor, then there can be multiple tasks running on the single executor also within the single node, right? So depending upon the number of cores of processor, the way you configure the job, okay. So based on that, there will be that many tasks spawned on each node. Let's try to see how we can create RDDs. Okay, so there are multiple ways to create. So you can create an RDD based on the data that is present in RAM, okay, or the data that is there in the hard disk, right? So it could be a file or it could be some collection type that is there in in the RAM, right? So let's say, for example, we have some data, right? So I'll say val sample data, right? So I'll create some sample data here. So this is basically a data ranging. This is a data which is a range, which is having values ranging from 1 to say some 50,000, right? I created some data which is a collection type, right? So Scala.collection, it's an immutable range which includes values from 1 to 50,000. This data is in memory, right? Now, this is within, this data is in the same machine, right? So you cannot have, a data set which is beyond the range of this machine, right? Which cannot be held in this, machine, right? Now, I'll use this data that is there in the memory, and I'll create an RDD out of it. For doing that, we will use a function called as parallelize, which is available as part of this Spark context object. Okay, so now this sample data variable is your Scala variable, right? So this is a Scala program. Now we are starting to use the Spark functions, right? So far this is all Scala. So now we'll use our first Spark function. So now to create an RDD, we have to use the Spark function, which is available from this Spark context. Okay, so I'll use the Spark context SC function. This parallelize function, and I'll create an RDD. So I'll say val. I'll say total data is equal to. I'll say SC dot parallelize. Okay. So this is a function that is available as part of the Spark context object, and I'm going to pass, this variable sample data. Okay, so I'll say create an RDD out of this sample data variable, right? So now, if you observe what has happened here, so total data is basically an what is this data type? So it is a Spark RDD, right? So this is an RDD of integers, right? So since the values that we are storing in this is basically integers, so what we got here is basically an RDD of integers. So this is how you create an RDD out of the data that is present in memory. Okay. Now, once you have the data, see what is happening here is now this RDD is distinct from your Scala variables, right? So this is automatically distributed. Okay. So if you are running this code on a cluster of machines, okay, so then this RDD processing is all done on a cluster. Okay, so right now we are on we are on local mode. So I'll show you in our next session. We will create a distributed cluster and we'll run this on Hadoop clusters. I'll show you how to do that. And when you do that, automatically this RDD what you have created is distributed, right? So you don't have to do anything to do this distributed processing. You just write the code the way you write your Scala applications, but because you're working on RDDs, now automatically you get the distributed programming features. So that's the biggest advantage of Spark. Now, see, once we have this, okay, once we have the data as RDDs, now you can apply all kinds of, so for example, now if I just see TOT data, okay, dot and look at this, the number of functions that is available, right? So all these are RTD functions. Okay, so you can do an aggregation, you can cache this, you can do a flat map, I'll talk about all this. You can do a group by, reduce. Okay, there's a whole list of functions that you can perform on this. So there is a map. Okay, so using map, you can basically, you know, pass a function and do some stuff. For example, I'll use one of this, right? So I'll use the filter function, right? So I'll do data dot filter. Okay. Now I'm going to, get all those numbers that are divisible by 2 from this data set. Okay. So I'll say filter, like what we did. Um, okay. Sorry. I'm sorry. Where am I? Okay. Now, what's happening. So I'm basically, applying this filter, using this filter, I'm basically now retrieved all the, um, values within this RTD, which is divisible by 2, right? So now what's happening? So now if you were to perform this operation, right? So this is, see, the moment you have this as RDD, see, if it was a Scala variable, right? Now this whole execution is happening on the same machine, right? But if this is an RDD, when you perform this operation, now this is performed on multiple machines. So you're doing this in a distributed way. So this is a very small, simple example. But when this is getting executed on a cluster, now this processing is happening in a distributed fashion. So collect is just sort of equivalent of forcing, basically showing the values of whatever this data set contains. So the result of toData.filter, now on that set, when I say collect, so it's basically showing me all that data. So when you're building Spark applications, I would say 90% of the time you're just using the RDD functions. Okay, so in our next session we will deal exclusively on that part, where we will be looking at all the different types of RDD functions and how to use them and what basically what does it do, right? And then a lot of this magic that you saw about Scala code, okay, may not be many times necessary because most of the functionalities are all built in. Okay, so the moment you have data as RDDs, you get access to a whole lot of functions, right? Now, the other advantage is, see, if you were to think of doing this in Scala or Java on an unstructured data, you want to build some query on an unstructured data, right? Now, if it is a structured data, then you can load it into an RDBMS and then you can write an SQL query, right? Now the problem is most of the data that exists, today is all unstructured data, right? So when you're trying to do an, analytics, you have to work with a lot of unstructured data, right? Now for unstructured data, you cannot, load them onto say RDBMSs, right? So how do you process unstructured data? So you'll have to write applications, which would, load that data and then, do all sorts of maybe, string manipulations or some other, you will have to basically hard code for all those things that you would have to do it on unstructured data, right? Now, that is a tedious process. Now, programmatically, it's a lot of work. And supposing if that data is, very large, which doesn't simply fit into one machine, then it becomes even more difficult because you have to code for, doing some parallel processing and all that, right? So all that is really, avoided by using this Spark framework. Okay, so for you, all you need to do is look into these Rtd functions and basically simply load the data and create RDDs and use the Rtd functions to transform or perform any sort of operations on this unstructured data, right? So it is as simple as that. So for example, you have whole lot of functionalities like group by, order by, map and all that. So simply use those functions, right? So that becomes much easier to write applications. So now we created an RDD out of the data that is already present in some Scala variable, or you can say in memory. You can also create RDD from the data that is there in a file, right? So which is there in hard disk, right? So for that you will use a different function. Okay, so you can see here for a Spark context you have many different functions, of which parallelize is just one function here, right? So you can use, for example, you can use the text file function to basically create an RDD out of data that is present in a text file. Okay, so for example, I can create a, I'll say val text file, okay, is equal to Spark context dot, I'll use the text file. So what it does is it automatically reads the data from this text file and it creates an RDD out of that data, right? So let's give some file name here. Read that file. So I'll say readme.txt.md. Okay, so you can load this data, right? So now you basically created a you can see here it has created an RDD of string. So the Scala's type inference is make sure that the data that you have loaded is is a string, right? So basically you created an RDD of string, right? So now once you load this, now you can use all the RDD functions. Okay, so txt file. Okay, so we have so many functions which you can use to get basically whatever the logic that you're trying to build. Now let me just try this. So we will look into the in our next session. Let us look into the structure of RDD and how it is loading that, right? So there I will talk about, because that is, I need at least it's a good 1 hour discussion on that. right? So I'm going to talk about the structure of RDDs and all the functions of RDDs in our next session. Okay, so now if you observe here, this gives you the number of lines in this file, right? So basically there are 98 lines in this file. So each of those lines is created as one value within this RDD, right? So so this RDD has got sort of 98 values or 98 records within this RDD, right? So each line has become one value or one record in this RDD. Okay, so for example, you can use text file dot like first, right? So the first line or the first string in this is something that says Apache Spark, right? So you get the first value which is there within this RDD, right? Now if you want to kind of like use the filter, right? So you want to filter. Now you have to provide a function which has to generate a Boolean value, right? So here, say supposing if you want to get all those lines that contain the word Spark in it, right? So I'll have to pass this as a function, right? So it has to filter, will basically filter based on whatever the function generates true for that, right? So now you recall the anonymous functions syntax that we generated. So I'll pass a function where I say I refer to every line in this text file as line. Okay, so this is an anonymous function, right? And I say use the line dot. So whatever the value that I'm taking here is basically a string, right? So that string has a function called as contains, okay? And I'll use that contains function and I'll just check for Spark in it, okay? So this would return true for those lines which has Spark in it, and it will return false for those lines which doesn't have Spark in it, right? So my filter will get me only those lines for which this function returns true, which means there is a Spark keyword present in that line, right? So I'm going to collect this as I'll say val, and I say lines with Spark, some value, okay? So enter this. So if you can observe, this is basically an RDD, right? An RDD of strings, okay? So if I say lines with Spark, sorry. Okay, so 19 lines out of the 98 lines in this text file contains the keyword Spark in it. My RDD name is text file. So on this text file, okay, I'm going to use the map function to map, and I'll say map, I'll pass a function here, okay, so an anonymous function. So treat each, line in this, each value in this text file RDD as line, and I'm going to say line dot, I'll use the split function which you saw earlier, okay, so split, okay, based on the space as the delimiter, okay. and see what happens. Okay, so what we got here is another RDD, which is an array of strings, right? So for each of the line in this text file, so basically I'm splitting them, and so I'm creating an array of strings for all the individual strings that are present in each of the lines of the of the file, right? So if I say supposing if I do this collect, okay, you can notice here all the lines, the individual words are like separated out, and it is now present as an array. So it's basically an array of strings. Okay, so each line is split into its individual strings. Okay, now see, I'm going to stop at this. Okay, uh, and in our next session, let us explore the RDD structure and all the RDD functions, and we'll start building the Spark applications and deploying it on say clusters, and explore more about what is there in the Spark core API. And so when we will look at how to create Spark context within a program, and what are the different ways in which we can configure the Spark context to basically execute this program in a local mode or on a cluster, and then all the different functions of RDD, which makes it actually easier. Okay,